Assalamualaikum warahmatullahi wabarakatuh. My name is Aflah Aditya from Information System Department, and we'll do the lab challenge on Module 3, implementing a machine learning pipeline with Amazon SageMaker. Okay, so in this lab, the challenge lab is predicting airplane delays. So the objectives of doing this lab is process and create a dataset from downloaded zip files, perform exploratory data analysis or EDA, establish a baseline model, perform hyperparameter optimization, and use metrics to compare the performance between models. I will start the process. So for the task 1, creating a Jupyter notebook with Amazon SageMaker. So the first thing to do is access the Amazon SageMaker and then create a Jupyter notebook. Okay, so now the notebook instances the status is already in service, so I can continue to the next task, opening the Jupyter notebook instances. So this is the Jupyter Lab environment. Then I can continue to the next task, which is task 3, loading the flight delays to the notebook. For this task, I just need to follow the instruction in the notebook. Okay, so this is in the Jupyter Lab. We just open the n_us here and then choose the flight delay student. In this Jupyter Lab, we can see the problem, which is predicting the airplane delays. We'll continue the first setup. Okay, for the first setup, I will try to run the code. Okay, it's shown here, it's on process, and this code is used for import the library that will be used in the next step. So I need to wait for the code until finish. Now I will continue to step 2, data pre-processing and visualization. First thing to do is download the files. Like this. Okay, so is the file is already downloaded and I can continue to the next code. Now all the files is already extracted and then I can continue to the next code. Okay, it's shown that it's already 16 files that already extracted. Then continue the next code. And this is the preview of the code and of the file. There are the background, the record layout, there are year, month, the flight date, etc. And there are so many information. Then I can continue to the load sample CSV file. And this is the code for view the row and column length in the dataset. Okay, for the code shape, uh, it shown that the amount of rows is around 580,000, and for the column is 110. And then the next code, uh, I will ask to review the first 10 row of the dataset. Okay, this is the code and this is the result. So it's shown 10 rows from 0 until 9. Okay, for the next code, it's for view the column names. Can be shown here, the column names. There are year, quarter, month, and etc. Okay, so the next code is print all the column in the dataset that contain the word del. It's for help to see how many columns have delay data in them. So just need to Okay, so this is the result, and then can continue to the next code. Okay, so for this code is for answer the question num number 1 until number 5. And this is the result. Each answer the question number 1, number 2, number 3, number 4, and number 5. For this code, it will show the origin and the destination in the airports. So there are 346 rows and 2 columns. This code is for print the top 15 origin and destination airports based on number of flights in dataset. This is the result. Then we can continue to combine all CSV files. Okay, so it's already combined by run all the code, and then can continue to load the dataset, load the combined dataset. Okay, next is print the first five records. Okay, so before load the dataset, the CSV is already combined, and then we load and preview the first five records here, the result, and then we can continue to the next code to answer the 5 questions provided. Okay, so this is the answer, the result of the code. After that, the next code is for define the target column. and this is the result, the code. So basically it's 0 here. The the rifle delay details. Okay, the result is 0 and the rest is 22,540, and continue to run the code. So it's for change the amount to be 0 for all the information, and then this code is for get the hour of the day in 24-hour time format from CRS dev type. Okay, so after we execute the code, uh, for the information that all information is already null, then we can continue to the data exploration. Then this is the result of the code. It's shown the delay class versus no delay. So we need to run this code to answer the question. Okay, so this is the result of the code. It's shown graphic, the graph, I mean, and then we can continue to run the other code. And this is the result. The result. Okay, so the result is for answer the question, and I can continue to the features. Okay, so after run the code, it's shown for the name columns and also the type. For example, it's year, the column name, and the type is integer 64. Okay, so for this code is for check the length of the dataset and the new column. So this is the amount of the sheet in the columns properties, and then this is for the details of the columns. And I can continue to run this code. Then this is the end of the step 2. The last is we need to download the folder and save in our file locally. Now I will continue to the step 3, model training and evaluation. First is train test split on the code. Okay, so this is the result. It's quite similar with the sample answer, and after try the baseline classification model, I will continue to the next code. And the next is train the model on the dataset that I already uploaded. Yeah, I think it's this time. Okay, so the sample code is already done. Then I can continue to model evaluation. It's to evaluate the train model that already created. And then this is the metrics for the training job. There are metric name, timestamp, and value. There are 4 record here. So for the next code, we need to replace the lab bucket name code with the name of my bucket in the Amazon S3. So this is the bucket name. We just need to copy and paste to the Jupyter Lab. Okay, so after I run the code for setup function to load the test data into Amazon S3 and perform a prediction by using prediction function, so I can continue to test the data set. Okay, so the the prediction on the test dataset is already done, and then I can continue to view a plot of confusion matrix and query scoring matrix, and also create a couple of functions. Okay, so this is the code to plot the confusion matrix. This is the result. There are true class and predicted class. Okay, so this code for the print the statistic and plot a receiver percent characteristic or ROC curve. So for the confusion matrix, on the left is the true class or the real situation, and then below is predicted class of the prediction. One is means that is delay, and zero is means that is not delay. Now, okay, then that's the end of step 3. I can continue to step 4, feature engineering. First is I need to build a code. Okay, so after run all the queries, so the first is add a boolean variable is underscore holiday that equals the holiday for the years 2014 until 2018. After that, run the download the CSV that have information on which speed precipitations snow and temperature for cities by airport codes. After that, import the weather data and also create a new column called airport and preview the date and create another column called pod. And this is the result. There are 5 lists, uh, uh, and it's same with the sample, and also is for check the missing values for all the columns. So it shown is the result. There are null and there are some amount in some information. Okay, so after run all the code, basically the process is same with the previous step, so, which is for create the for plot confusion matrix and ROC curve. But in this step, we change for the function and the code, so it will generate the different confusion matrix and the ROC curve. Okay, so after run the code for try the XGBoost model, um, can continue to evaluate the model. Okay, after that, get after get the predict the target and then calculate the values. Continue to plot confusion matrix and then the ROC chart. So after test the code and then we got the third confusion matrix and the ROC chart. So basically it's different from the two confusion matrix previously. Then I can continue to hyperparameter optimization. After I wait for the training job to finish, uh, to check whether the hyperparameter tuning job is complete or not, we can see on the Amazon SageMaker training and then hyperparameter tuning jobs, and it shown here that it's still in progress. So basically, the result is like this. After we after the tuner is finished, then it just run in the next code, the confusion matrix and ROC chart code. Uh, so basically, the result of the confusion matrix and the ROC curve will be similar with the example here. So in my case, the first ROC curve is 0.5, the second is 0.51, 51, then the third is 0.55, and this is the last. Maybe it can be similar like the sample, so I assume that 0.57. So the conclusion is when I try or add some more or some feature or function or tuning, then the confusion matrix will be different and the ROC curve will be increased and more accurate. And the conclusion is using this machine learning, uh, so we can predict the flight schedule, the delay of the flight schedule due to weathers. I think that's all from me. Thank you for your attention. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.